Assalamualaikum and selamat sejahtera. Okay, so hari ni we will continue with still in topic series. Okay, sequence and series. Okay, so the subtopic we will learn today is about series. Okay, Bismillahirrahmanirrahim. Okay, so Bismillahirrahmanirrahim. Allahumma ftah alaina himmataka wa syra' alaina min hazaini rahmatika ya arhamar rahimin. Amin ya rabbal alamin. Okay. Okay, so I will share screen. Okay, so the subtopic today will be series. Okay. Okay, so before this kita learn about sequence, right? Okay, sequence ni dia more kepada term. Okay, what is the first term? Okay, comma and then the next term. Okay, so series ni dia adalah summation of the term of sequence tu. Okay, so here. Okay, the terms of sequence are added together. Okay, then we obtain what is known as a series. Okay, so let's see before this. Okay, term of sequence 2 we have, okay, let's say 1 and then comma and then another number, comma, another number and comma. Okay, so for series, okay, the symbol is S. Okay, so we just have to add all the terms. Okay, so in this case it stop until at the fourth term. Okay, so this is finite series. Okay, there can be also infinite series. Okay, so for series we just use this notation. Okay, Sn. Okay, from K1 until N. Okay, and then this is the term of sequence. Okay, terms of sequence. Okay, so it can be either K equal to 1 or also it can be K equal to 0. Okay, then sum of finite arithmetic series. Okay, so arithmetic is about addition. Okay, so what we have to do is we just add. Okay, let's say before this the sequence is 1, 2, 3, 4, 5. Okay, and then we just have to add everything. Okay, so it will be 15. Okay, and then we can write in the correct term. Okay, or also we can write vice versa. Okay, starting from the last term to the first term. Okay, last term to first term. Okay, here we want to show you how to calculate in simple way. Okay, let's say term of sequence to until 100. Okay, let's say 1, 2, 3 until let's say 200 something. Okay, so it will be difficult to calculate manually like this. Okay, so there is a simplified way. Okay, so this is the example. Okay, so let's say we add these two equations. Okay, let's say we add these two equations. Okay, so it will be 2s. Okay, so here we can see. Okay, 1 plus 5 will be 6. 2 plus 4 will be 6. Okay, until the end it will be 6. Okay, so it will be simpler to calculate in this way. So there are five numbers of 6. Okay, so multiply with 6 we get 30 for 2s. So divide by 2, we get single S, and then 30 divided by 2, we get 15. Okay, so this is the simple way. So what we have to do is, we have to add in the correct order with the what we call it, yang terbalik punya order. Okay, so okay, here this is okay. So now we want to come up with the formula. Okay, so this is the correct order one. Okay, this is the correct order. Okay, correct order. Okay, and then this is the, I don't know what to see, vice versa order. Okay, order where it start with, okay, with the last term. Okay, so here, okay, so this is the first term. Okay, first term. Okay, and then this is the last term. Okay, this one is the last term, and this is the first term. Okay, so okay, so we just have to add up. Okay, okay, so in this case, I will okay, we will make it closer, so it will be easier for you to have a closer look. Okay, so okay, so now okay, so this is the last term. Okay, this one should be moved as well. Think here. Okay, okay, so we just add. Okay, this one. Okay, so we just add. I'm using this color. Okay, so and then okay, last term we will add if the first term, which is A. Okay, and then okay, this one will be add with the second term, which is A plus wait, okay, should be okay, this is the first term. Okay, and then we add up the second term. Okay, this one. Okay, okay, A plus D. Okay, this one plus as well. Okay, then next color will be this one. Okay, so then this color. Okay, this one. Okay, which is the last term, we will add here. Okay. Oh, okay. So this will be A plus K minus 1 D. Okay, so plus. And then, so we will have, okay, I just write in blue color. Okay, so we will have 2A plus K minus 1 D. Okay, and then, okay, plus, okay, this one, 2A. Okay, and then plus K minus 1 D. Okay, dot, okay, plus, this is the last term. Okay, so this will be 2A plus K minus 1D. Okay, so this is exactly the same. Okay, so this will be 2SK. Okay, actually this one is similar. I'm just showing you how to get these terms. Okay. Okay, so okay. So lastly we get 2SK is 2, yeah, this is okay. This is what we want. Okay. This is the formula to simplify, to sum up all the terms. Okay, let's say the terms, the sequence has many terms, let's say until 100 terms. Okay, so we can use this formula. Okay. Okay, so this is sum to k terms, okay, of arithmetic series with first term A and common difference D. Okay. Okay. This one. Okay. Okay. Sum of arithmetic series. Okay. So now we are going to learn how to use this formula. Okay. So in this example 6.12, okay, find the sum of arithmetic series containing 30 terms. Okay, with first term 1 and common ratio, common difference 4. Okay. So the keyword here is sum of arithmetic series, okay, series, and then 30 terms. That's a lot, right? So we have to use the formula. Okay, and then the first term is 1, and then given common difference is 4. Okay, so now we are going to use this formula. Okay, so just write down the formula that we have. Okay, so we just write down first. Okay. Okay, so SK is K over 2A plus K minus 1 D. Okay, so K we are given is 30. Okay, terms, how many terms? And then A is the first term, which is 1. And then D, common difference is 4. Okay, so just input into the formula. Okay, so this will be 30 over 2 K to 1 plus 30 minus 1, and then D is 4. Okay, so just calculate it. Okay, so we have 15. Okay, and then 2 plus 29. 4. Okay, finally we get the answer 1770. Okay, so this is the sum of arithmetic series. Okay. Okay, and then we look at example 6.13. Okay. Okay, this is just the same, but it's written in just slightly in the other way. Okay, slightly different, but it's just the same. Okay, so here find the sum of arithmetic series. Okay, with first term 1, common difference 3, with last term 100. Okay, so here, okay, still we have to find the sum of arithmetic series. Okay, now we are not given the K. Okay, we don't know how many terms are there, but we are given with the last term. Okay, so how this one? Okay, so we know that, okay, the last term is equal the formula for last. Okay, so just write down the formula, the given input first. Okay, so A will be the first term, which is 1. Okay, D is 3. Okay. Last term. Okay. Last term is 100. Okay. So, do we know what is the formula for last term? Okay. So, if we look back here, up here. Okay. Where is the last term? Okay. So, here this is the last term, isn't it? Here. Okay. So, A in bracket A plus in bracket K minus 1 and then multiply with D. Okay, so this is the formula, okay, the general term for last term. Okay, so A plus K minus 1 D. Okay, so it's the same here. So we are going to input A and D into the last term. What we call it, formula. Okay, so here we will like okay, A is 1 plus K minus 1, D is 3. Okay, so now we are going to get the K. So 1 plus 3K minus 3. Okay, so we'll have, okay, this one will be 99. Okay, 3K minus, okay, 3. Okay, so 3K will be equal to 102. Okay, and then K we will get will be equal to 34. So, okay, now, not yet, okay. We have to answer how much is the sum of arithmetic series, which is SK, okay. Again, SK, what is the formula? So, 30, okay, so the general term will be like K over 2 and then 2A plus K minus 1 K minus 1 D. Okay, am I correct? Yes. Okay, then so we just put back what is K? 34. And then 2, 1 plus K 34 minus 1 and then D is 3. Okay. So lastly we will get the answer is equal to 1717. Okay, so this is the sum of arithmetic series. Okay. Okay, next. Okay, now we are going to learn how to do the sum of finite geometric series. Okay. Okay, so again we have to remember, okay, when it involves geometry, it will involve, okay, multiplications with ratio. Okay. Okay. So, okay, so now, okay, so this is the example. So let's say we have, okay, this is the geometry progression, okay, in terms of sequence. Okay, this is the sequence. Okay, now we are going to find, okay, so this is sequence. But what kind of sequence? It is geometric sequence, okay? Because, okay, as you can see, this one will multiply, multiply 1 over 2, okay? Multiply 1 over 2. So this is geometric series, okay? So and then what we are, so this is geometric series, geometric sequence. Okay, so now we are going to calculate the geometric series. Okay, so we have just to add up all the terms here. Okay. Okay, so okay. Okay, so this is okay, so this is we want to simplify how we want to calculate the sum of geometric series, okay, in a simple way. Okay, so this is normally what we do, okay, and then we have to multiply, okay, okay, 6.1, okay, multiply equation 6.1 by common ratio 1, 2, isn't it? Okay, so we have identified earlier, the common ratio is 1/2, okay. Okay, so this is, I just have to add up common ratio, okay. So not to confuse you, okay, common ratio. Okay, so when we multiply with 1/2, okay, so we just put here everything we will multiply with 1/2. So 1 multiply 1/2 will become 1/2, okay. Everything here. So I just show for the first and last term, multiply with 1/2. So we will get 1/32. Okay. So here we just subtract the equation 6.2 here. Okay. We just subtract with the 6 point, okay, 6.1. We subtract with the 6.2. So we will get, okay, 1, okay, minus 1/32. Okay, macam mana? How I want to say? Okay. Okay, we just, okay, so we notify here that, okay, okay, when we subtract, this one cancel, okay, cancel because it's the same. Cancel. So what left is 1 and 1/22. So that is how we get 1 minus 1/22. Okay, 1/22. 32, sorry. Okay, so okay, and then okay, so what we do, okay, so we put it in general term. Okay, so this is the normal term, okay. A plus AR, okay, R is the common ratio, okay. R squared, okay, and then for the second equation, we multiply with R, okay. So everything here with R. Okay, so when A, okay, multiply R, so multiply R here, so okay, and then it will become A to AR, okay. And then for this one, multiply with R also, so it will become ARK, okay. R minus 1 multiply R, so it will be -1 plus 1, so R0 equal to 1, okay. So that's how it become AR to the power of K, okay. Multiply R, yeah. Okay. Multiply R as well, okay. So okay, so you can see that this is, okay, the formula to calculate sum of geometric series. Okay, so this one is for geometry, okay. The term that we multiply with common ratio, okay. So now we are going to calculate sum of infinite series, okay. Okay, so here, okay, what is, okay, we start, how I'm going to say this, okay. Okay, start at 0, move at the length 1. Okay, total distance moved is 1. Okay, so now we are moving at 1. Okay, so 1 here, is 1 here. Okay, and then next we are moving to the here. Okay, now we are moving to the second term, which is 1/2. So we have to add up 1 plus 1/2. So it will become 3/2, or it will become 1/2. Okay. Now we are going to continue here until here. Okay, so 3/2 plus 1/4. Okay. Okay, this to make to not. I try to not making you confused. Okay, so 1/2 plus 1/4. Okay, so 3/2 plus 1/4. So 6/4 plus 1/4. We have 7/4. Okay, so if we want to simplify, to make it, to simplify, so it will become 1/3/4. Okay. Okay. We are going to find out actually either it will converge or not. Okay. So here. Okay. Okay. So okay. Previously we have so 1. Okay, converge to 2. Okay. The sequence of total distance moved given previously. Okay, so this one yang we calculate previously. Okay, this one. Okay, until here we get 1. Until here we get 1/12. Until here we get 1/3/4. The series. Okay, so until here, isn't it? Calculate. Okay, so it can be and so on. Okay, so meaning here, this is sequence of partial sums. Okay, maksudnya we calculate the sums at certain point. Okay, as we moving to the last term. Okay, so here, okay, it's okay. Maybe you can see when we do example later on. Okay, so okay, sequence Sn converge to a limit S. Okay, so okay, and then clearly not all infinite series will converge. Okay, for this example, okay, the series here is not converging. Okay, it will move until infinity. Okay, okay, so this is the sequence of partial sums. Okay, 1, 2, 3, 4, 5, maybe until 5. Okay, 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 until here the sums. Okay, so this is what we call sequence of partial sums. Okay, so until here it is okay 1. Okay, this is 3, and then this is 6. Okay, 1, 3, 6. Okay, and then 10, and then 15. Okay, so this is what we call sequence of partial sums. Okay, so in this case, the sequence, the sequence, okay, diverge to infinity. Okay, which means this is divergent. Okay. Okay, next, sum of infinite geometric series. Okay. Okay, so we know already. Okay, this is the sum for to calculate for geometric series. Okay, and then okay, now we are going to calculate. Okay, let's say the term will be infinity. Okay, so so when k is going to be infinity, rk will be 0. Okay, when r so lastly we will get this one. Okay, so I'm just showing you how to get this one. Okay, this is the sk formula. Okay, a1 minus r to the power of k, and then divide with 1 minus r. Okay, so now k sk going to be infinity, going to infinity. Okay, so we just convert k into infinity. So this one s will be s infinity. Okay, a 1 minus okay 0. Okay, because infinity will be 0. Okay, and then 1 minus r. So finally we get s infinity a minus 1 over r. Okay, so here it says that this one is only valid for r less than 1 and then bigger than -1. Okay, why? Okay, now I'm going to show you. Okay, 100. I have to pause for a while. Okay, so I'm going to charge my laptop first. I have to stop share. Okay, so now we are going to calculate to use this example. Okay, we calculate using this example. Okay, so here sum of I is okay. Let me adjust the key. Okay, so this is the sum of infinite geometric series. Okay, so now this one is infinite. Okay, the keyword here is infinite. Okay, so this is what we are going to use. Okay, so the first one, for example 6.14e, the instruction is find the sum of k terms of the following series and reduce the sums to infinity. Okay, here we have to find the s infinity. Okay, so first identify. Okay, this one is geometry, isn't it? So this is, it has to multiply with 1 over 3. 1 over 3, right? Okay. Okay, so now this is the geometry series. Okay. Then identify the first term A and common ratio R. Okay. So here A is so here A is 1, isn't it? Okay, my laptop's getting hotter, so it's quite hard to write here. It's come hang, okay. Okay, so here is for 1. Okay, so A is 1, isn't it? Okay. And then 1 over 3. How should I do it? Okay, maybe I think I have to end here, I think. I cannot write anymore. It's become slower. Yeah, okay, so that's it. Okay, so we continue in next lecture, okay, for this one. Okay, have to stop share. Okay, so that's it. Okay, Assalamualaikum and thank you for your attention.